proving identities. Typically you want to start with the side that's containing the more complicated expression. So something that usually has like a lot of stuff going. 2 or 3 things being multiplied, added, subtracted, something. And there's actually more than one way to prove it. As long as you prove the left and right are equal, it doesn't matter to me how you do it. But this is the easiest way. And then you're going to rewrite sums or difference of quotients as a single quotient. So what I mean by that is if you were to have, and I'll do algebra with it. If you had x over 2 plus y over 2, you could rewrite this as x plus y all over 2, right? Because it has a common denominator. We're going to see instead of having a denominator of 2, the denominator might be like sine theta. And then we'll just rewrite it as one single quotient. We're also going to consider converting all of any of the trig expressions we're given into sine and cosine only. Because if everything's in terms of sine and cosine, a lot of stuff will cancel out or be able to turn into 1. Use your trig identities, and then always keep your goal in mind, which is the left side equaling the right side. Now the first 2 examples are just like the bell ringer. They say write each in terms of sine and cosine only. So we're going to use our formula sheet. You want to have it side by side. Have your formula sheet out, handy, visible, and your note sheet. I'm going to have the formula sheet on the board so I can reference it. So again, the directions tell us, this is not a proving one because we don't have an equal sign. Just write each in terms of sine and cosine only. So we go to our formula sheet. We find out what the tangent is. The tangent has 2 options, 1 over cotangent. We want to choose sine and cosine. So this would be sine theta over cosine theta. These are equivalent expressions, just like 1/2 and 2/4 are equivalent fractions. These are equivalent. They mean the same thing. The secant, go to your formula sheet. 1 over the cosine. Now, can we cancel anything out or divide it out? Because we don't have them in opposite locations, meaning multiplication division. You can multiply those straight across the top, and we'll get sine theta. What do I get when I multiply cosine theta times cosine theta? Squared. This would be cosine squared theta. And that's your final answer for this one, because they just wanted it in terms of sine and cosine. Next one, cotangent, what would I rewrite that as? I'm on our formula sheet. Cotangent. Cosine over sine. Talking to myself up here. Cosecant, rewrite that as? 1 over sine. Thank you. And then the answer is going to be almost the same. We're going to get cosine times 1 is cosine. But they're kind of flipped. Sine times sine would be sine squared. All right, now on the back, it actually says establish each identity, which means prove each identity, which means prove the left is equal to the right. You're going to do essentially the same thing. I would suggest rewriting everything in terms of sine and cosine if possible. You want to look for things that, if you see any squared terms, you obviously want to focus on your Pythagorean identities. But you're just getting, the last line of your work could be different than the last line of my work as long as your left side equals the right side, and when I read through, it makes sense what you did. Okay? You cannot just write secant equals secant and assume to get the problem right. You have to show work just to justify what's canceling out or simplifying. So, again, I suggest, like what we did on the front, change everything to sine and cosines. Okay, so cosecant, that's 1 over sine. So let's change this to be 1 over sine. tangent has two options, but again, you want to pick the one that has the sines and cosines in it. So tangent of theta is equal to sine theta over cosine theta. And then it's up to you. Some students like to change the other side also, and then they'll just get like a fraction equals a fraction. Some students like to leave this secant and they'll end with secant equals secant. I don't care. I think last year most people liked to change this one also, so that's what I'll do. Secant is our 1 over cosine. I put your notes on your desk for you. You're welcome. And then on the left-hand side, we know that the inverse of multiplying and dividing would undo one another. So the signs cancel out. We're left with 1 over cosine equals 1 over cosine. And usually on my answer key, you'll see me do this. Just prove, little check that I have left side equals the right side. Again, the last line of your work, instead of this, could be secant equals secant. I'm just going to put or. Okay? Because if you left the secant as is and you got 1 over cosine, you could then say that that is the secant and secant equals secant. Most of you will prefer the 1 over cosine equals 1 over cosine. Left equals right. Done. All right, now the next one is a little bit harder. It's actually really simple, but to understand why, I guess, the negatives are going to go away, but I do want you to understand why. So you can use the even-odd properties that if you have sine of a negative angle, it becomes negative sine of a positive angle. So this negative will come up front. It would become negative sine theta. Now, when you have this squared, you really are squaring the quantity. Okay? So I used the even-odd property that says sine of a negative angle equals negative sine of the positive angle. If you want to write down what I use, because we're just glancing at it, that's what I use to get that. Now, cosine is the weird one. Cosine of a negative angle is equal to just the positive angle. So the negative actually just disappears. And this will just become cosine theta squared. Now, the reason I told you the negatives just go away, we saw this one goes away. But when you move it out front, this is technically a -1 times sine. What happens when you square -1? It becomes positive. Okay, so whenever you square the -1 and square the sine, you're going to end up with just sine squared theta. So the negative, when you have a square, just goes away. When you square cosine, it's going to get back to cosine squared theta. So again, what I was telling you is the negatives just really disappear. Left with sine squared, cosine squared. And then look at your identities. Sine squared plus cosine squared equals 1. So this whole thing over here is 1. So 1 equals 1. We've proven that the left side is indeed equal to the right side. Anytime you see squared functions, you do want to think about your Pythagorean identities because they might help you to prove left and right are equal. All right, next one. Now notice we do have sine squared and cosine squared, which is kind of hinting to me that I'm going to get that at some point. But I also have some other stuff in here, cosine and secant. So I'm going to go ahead, let's rewrite these and see if we can get anything to simplify, cancel out, make this a little bit easier. So cosine, yes, cosine is equal to 1 over secant, so if you want to do that, you can. But most students like to leave things in terms of sine and cosine always, just so that they're always cosine and sine. So I would actually leave this, personally, cosine over 1. Secant I would change to be 1 over cosine. And then everything else I'm going to keep the same, because it already has sines and cosines. Now we should notice that the cosine thetas, we do have one on the top and one on the bottom, so those would divide out to leave me with just 1 over 1, which is 1. Now, if you have the extra formula written that I wrote on your paper, which I think was cosine squared equals 1 minus sine squared. You can then say that cosine squared equals cosine squared. Now, some students would prefer to use inverse operations and actually get it to look like this. So, the inverse of subtracting sine squared would be to add sine squared. Well, let's put that in the right order. And then you get the actual identity. Sine squared equals cos squared plus cosine squared equals 1, which would mean 1 equals 1. Final line. Now again, an alternate method when you got to this point is if you have that extra formula written up here. Remember, all of these you can have 2 additional formulas. If you look back on one of your other formula sheets, we wrote them on there for trig. One of the formulas tells you cosine squared equals 1 minus sine squared. If you notice that, you could just say cosine squared equals cosine squared and be done with your check. Because you would have 1 minus sine squared, which is the cosine squared. So cosine squared equals cosine squared. That's an alternate ending to the problem. You just have to get that the left and right are equal in a logical fashion. That makes sense. All right, the next one, as I said, the negatives are just going to go away. And that's because you're going to take it out. Cotangent does come out front. You can see in our formula sheet. And for cosecant, it also would come out in front. So this would be 1 plus negative cotangent theta quantity squared, because this is really a negative 1 cotangent. The negative would come out front to be negative cosecant of theta quantity squared. And then you square the negative. So whenever I square a negative 1, it just becomes a positive 1. So I end up with 1 plus positive 1 cotangent squared theta. Again, squaring the negative 1 makes this a positive. And if you notice, that is your identity. So since 1 plus cotangent squared equals cosecant squared, I will take this, replace it with cosecant, because this equals cosecant squared, and I'm done. Cosecant squared equals cosecant squared. See if you guys can try the 2 closure questions. And then your homework is on the next page, but you're going to have to use notebook paper. So this page is like a book copy page, and you will use this for all of 7-3's homework. So if you want to tear it out, you can. But you're just doing numbers 1, 2, 9, 10, and 19 through 22, which is typed out on your note sheet at the bottom. 1, 2, 9, 10, and 19 through 22.